In this problem, we're told to calculate Earth's mass given the acceleration due to gravity at the North Pole is 9.83 meters per second squared, and the radius of the Earth is 6,371 kilometers from the center to the pole. B. Compare this with the accepted value of 5.979 times 10 to the 24 kilograms. So what we're trying to do in this problem, at least for A, is calculate the Earth's mass. So what we're trying to do is solve for M, and so I'm going to denote the mass of the Earth by uppercase M. In this problem, we're going to use lowercase m, which is just going to denote the mass of an arbitrary object. So let's write down the information we're given to. So we're given the radius, which is 6,371 kilometers. We're given g at the North Pole, which is 9.83 meters per second squared. And then what we're going to use in this problem is g, uppercase g. And so what this stands for, or what it is, it's a gravitational constant. So this is just a number you have to memorize, which equals 6.67 times 10 to the minus 11. So that's the information that we're given. And so what you need to do to solve this is you need to know a certain formula. So this formula is based off Newton's law of universal gravitation, which basically tells us F, which is the force, is equal to G, which is the gravitational constant, multiplied by M. And so M times M. And so these are just the mass of two objects. In this case, M is going to represent the mass of the Earth. And then the lowercase m is just an arbitrary object. And then you divide that by the radius squared. So what F represents in this case is just going to be the force of gravity. And so we know the force at any point on Earth is usually just mg. So F in this case is just equal to mg. So what we can do is say mg equals this formula because they're both just the force of gravity. So times m over m r squared. And so m in this case, when we do this, like when you just use mg normally, it just represents the mass of an object. So m and m in this case are going to be the same mass. They're just the mass of an arbitrary object. So you got to keep that in mind. And so what we want to do now is manipulate this equation and cancel out the m. So what you should notice is we can just take m from both terms. So you would just get g equals gravitational constant times m over r squared. And so what we can do now is multiply both sides by r squared and then divide by g, and you would just get m equals g, right, times r squared, and then divided by the gravitational constant. And so what this is going to allow us to do is solve for the mass of the Earth, right? Because m represents the mass of the Earth. And so all we got to do now is basically just plug in the information we're given. So when I say g, we're choosing the g at the North Pole. And so the radius is 6,371 kilometers, and then g is just the gravitational constant. And so when you do this, you need to make sure your radius is in meters, because this is in meters and this is in meters, right? So we need to make sure this is in meters and not kilometers. So to convert it, you basically just got to multiply by 1,000 because there's 1,000 meters for every kilometer, or you can just write it as times 10 to the 3. So this is just equal to 6.371 times 10 to the 3 meters. And so now what we got to do is just plug in. So the mass is going to be equal to g, which is 9.830 times the radius squared. So 6.371 times 10 to the 3. And so keep in mind it's going to be squared, and then divide by g. So g is just the gravitational constant, 6.67 times 10 to the minus 11. And then, yeah. So what you want to do is just go ahead and plug this in. And so when you go ahead and do that, you're going to get the mass of the Earth is 5.982 times 10 to the 24 kilograms. So this right here is going to be your answer to A. So this is going to be the mass of the Earth given using this acceleration, or just using this acceleration due to gravity. And so this is A. And so for B, we're asking to compare this value to 5.979 times 10 to the 24. So we have 5.982 times 10 to the 24. And then we also have 5.979 times 10 to the 24. And so what you should notice is that the value that we found is actually going to be greater. So this is going to be greater than the value they give us. They just say compare it, so I think they just want us to realize that our value is bigger. But yeah, so I don't really know what they want you to do for B, but essentially the answer we found is bigger than the one they gave us. So yeah, that's going to be your answer for B. And then, so these are your answers, and hopefully you found this useful.